Alright, so the first thing in order to calculate a property is to calculate a sample space. Now, a sample space is a set. So if we were going to use any type of notation, we'd use the braces. Or I used to call them fancy brackets, but the braces. It's a set of all possible outcomes. Like, for example, you flip a coin. What are the outcomes? Heads or tails? And so if we were to write them, we'd write it like this: heads or tails. Roll a six-sided die. What are the outcomes? Yeah, 1, 2, 3, 4, 5, 6. So these are, I would say, simple sample spaces. But sample spaces get big in a hurry. And if we're flipping a coin, that's great. If we're rolling a die, that's great. But what if I said something like this? Well, first off, we okay with this? Alright, now, what is a sample space for rolling two six-sided die and adding them together? Now, one of the nice things about this, and I'm sure in your head you're already developing a plan to do this, I'll just say this: we can use tables, charts, Venn diagrams, which we'll get into a little bit with. Tables, charts, Venn diagrams, trees. We can use all of those to write out a sample space. Now, when you're rolling dice, and we're rolling two six-sided die, and alright, say Alright, say like that. What's the sum of those two numbers? 9. So what we need to do is we need to come up with every single possible outcome that could happen. And the best way when you're rolling dice like this is to draw a table. So there's the top of the table. 1, 2, 3, 4, 5, 6. And that would be 1, 2, 3, 4, 5, and 6. So we might call this die 1, die 2, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. This is a typical setup for the sample space of rolling 2 die. And this could be just, we could be multiplying them together, we could be adding them together, we could subtracting them. We could do all sorts of different things with it. And this is going to be, instead of actually writing a set of these, because the set would be enormous, the table would be just good enough for us. So now, in this case, I'm adding them together, so I want die 1 plus die 2. So in each box, what's 1 plus 1? Alright, that's 2. What's 2 plus 1? And then 3 plus 1. 4 plus 1. 5 plus 1. 6 plus 1. Alright, so that's column 1. Now the next column, 2 plus 1 here would be, what would go here? Here? 2 plus 4? Two plus 5 is, and then, do you see a pattern? The nice thing about it is, when you're working with dice, a lot of times you get a pattern, where it's going to be 2, 3, 4, 5, 6, 7, then 2, 3, 4, 5, 6, 7, 8, 6, 7, 8, 9, 7, 8, 9, 10, 8, 9, 10, 11, 9, 10, 11, 12. So we were able to create the entire sample space. How many different items are there in the sample space? How many different boxes are there? There's 6 of them here, and there's 6 of them here. There's 36 different outcomes, depending on this. Oh, it'd be easy. All you have to do is say, well, there's 6 in one, 6 in the other one, multiply them together, you get 36. That's it. Well, that would be for the number of outcomes. Now, if I said, what's the probability that you roll an 8? Or that the sum is an 8? So this means the probability, the sum is an 8. How'd you get 5 out of 36? Yeah, that's all you do. And this is why having a sample space is so important. Is 1, 2, 3, 4, 5. There's 5 8s. So there's 5 out of the 36 numbers in here. So basically a probability, once you're able to create the sample space, is really simple, because all you have to do is count up the number that you're looking for, and you can put it over 36. Now, here's another one. What's the probability that the answer is even? Well, how many total are there? 36. Now count up all the even ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Yeah, and that is equal to 1/2. Does that kind of make sense that the probability would be 1/2? Why would it make sense? Okay, you have 2 die. How many of these are odd? 3, which is how many of 1 die? Half. And then you have half of this. So you have a lot of halves going on. You could have something like this. The nice thing is, if I say, hey, what's the probability that that the answer is a multiple of 3? So you have to ask yourselves, all right, right off the bat, how many are there? There's 36, right? Now your multiples of 3 would be 3, 6, 9, 12. And that's okay, that's as far as it goes because 12 is our biggest number and 2 is our lowest. So count up the number of 3's, 2 3's. Count up the number of 6's, 1, 2, 3, 4, 5. So we have 2 plus 5. Count up the number of 9's, 1, 2, 3, 4. And count up the number of 12's, which is 1. 5, 10, so that's 12 out of 36. So the thing is, once you get your sample space, when it comes right down to it, once you get your sample space, you can calculate any probability that you want from it. And all you have to do is pay attention to what you are actually looking for. That's what you want to be able to do. Any questions on something like that?